Edureka, and I welcome you all to this. Hello everyone, this is Wasim from Edureka, and I welcome you all to this live session in which we will make a data science project from scratch. So let me get a quick confirmation if you guys can hear me or not. So if I am audible to you guys, please type yes in the chat box. Now that I'm getting a lot of confirmation, let us begin our session. So in the last session, we covered the data science lifecycle processes until the visualization part, where we could draw conclusions from a given data set. In this session, we will make prediction based on our understanding of the data using either regression model or a support vector machine model. So I hope everyone is clear with the agenda. Also, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. And enroll to Edureka's Data Science with Python certification program. The link is given in the description box below. Now, without any further ado, let us begin our project. So we're going to start with the Jupyter notebook itself. So first of all, I'm going to import some dependencies. Like I'm going to import, okay, just let's name it Data Science Project 2, right? So I'm going to import a few dependencies like pandas as PD, import numpy as np, import cbond as SNS. So when I do this, I am expecting it to run properly without any errors, which it has. So now what I'll do is I will make my data or load my data. So the first step is to gather the data that you should look for. I mean, first of all, you have to make sure that you have the exact data that you want from the source. So for this, I have downloaded the data of 500 people with their height, weight, and BMI, which is body mass index. Okay, I'll just show you the data set itself, and I have chosen a relatively smaller data set because I want it to be a little easier for the beginners also to understand how it works, so that it'll be easier for them to use it for bigger data sets later on when they are perfect with the all these processes that are covered. So we'll take a first look at our data, guys. So this is our data, right? I'll just take a look at first few, like the first 5 rows. So this is our data, guys. We have 4 columns, and we have gender, which is male and female. Then there is height, weight, and index. So as you can see, there's a value like 423, 433 in this index value. So I'm going to get to that later. Before that, let us also take a look at the data from last 5 rows. So we have 499 entries starting from zeros, which makes it 500. Also, let's do a few more commands. So we have height, weight, and index. Now I'm going to install a few dependencies which are going to be required when we are making the model. So for that, of course, we have to install the sklearn, which is a machine learning library, guys. And if you want to know about sklearn in detail, there are so many tutorials on Edureka that we have already made in detail that you can use to learn it from. Okay, I'm just going to import all the dependencies here only because and I'll explain it when we get to that part in the program, so that there is no confusion about what we are doing here, right? Accuracy score. So I'll explain all these things that I'm actually importing from over here from the sklearn.metrics. So don't worry, guys. I'll just explain everything when we get there. And then we have sklearn.preprocessing, import standard scaler, and yes, after that we want label encoder. And this is a very interesting label encoder, guys. You'll be very happy to learn about this when we get there. And after this, I want to just import one more thing, which is from sklearn.preprocessing. model selection. I'm going to import train, test, and split. So there are no errors here. So I have just installed all these dependencies, but we'll come to this part later on. Before that, I want to change a few things from my data. So first of all, let's take a look at our data, guys. So we have gender in the form male and female, but I want it to be categorical. So I'm going to change it to 0 and 1 using the label encoder. Now you must be wondering what exactly does a label encoder do. So it is nothing but it is used to encode the target labels with value between 0 and n classes minus 1. So this transformer should be used to encode target values, that is y, and not the input. I'll tell you what the input and target values are. All right, so we're going to use the label encoder here. So I'm going to write it as gender is equal to label encoder, yes, and data. After this, we have the column name, which is gender is equal to gender dot fit transform. Now you must be wondering what exactly is fit transform. I'll tell you guys, fit transform is nothing but it is used to fit the label encoder and return the encoded labels, right? So I'll use fit transform here and data gender. So let's see, no errors, guys. Now when I take a look at the data, we have gender and in the form 0 and 1. So for each male value we have 1, for female value we have 0. That's how it works, the label encoder, guys. Now what I'll do is I will have to make a few changes to the indexed column as well. So we're gonna replace it with different values, or we're gonna give them labels. So for that, we're gonna use something called pd.cut. So I'll tell you what it is. We use the cut when we need to segment and sort data values into bins. So the function is also useful for going from a continuous variable to a categorical variable. Right now we have a continuous variable and we want to go to categorical variable. So for example, cut could convert ages to groups of ages ranges and supports binning into an equal number of bins or a pre-specified array of bins. So to do that, I'll take one variable, let's say, wait a minute, bins is equal to, I'm going to give it some values, -1, 0, 1, 2, 3, 4, 5. All right, and after that we take the health is equal to, let's say, okay, now I have to give a few values. So right now we have 6 values for all these places we have. So I'm going to use, first of all, let's say the person who is going to fall below 19, let's we call it as extreme, or we call it as malnourished. Then we have, let's say, underweight, right? And then we have, let's say, fit, and after that we have, let's say, slightly overweight, and then let's say we have overweight. Last but not least, we're gonna have, and let's just say we write it as extremely overweight. Yeah, that sounds about right. Right, so after that we'll have to make a few changes. So index is our column name and we use the pd cut. Now in this we are going to have to specify a few values. So first of all we have to mention which column, that is a pd index, and after that we have to write bins, which is equal to bins here, and labels we're going to use as health. And now we will write one more line of code. All right, we can do that later. So no errors here. We will check the index column now. All right, so we have overweight, fit, overweight, slightly overweight, all these values that we have in the column over here. We have replaced it, all these 4, 3, 2 values with these labels that we have in the health, this list we have over here. So we have replaced it basically. Now what we'll do is, let's get a count also. So we will get a count for all the values specifically, or we can get the value counts as well. Wait a minute, there's something wrong. Okay, this has to be counts, not count. And so for extremely overweight, we have 198 people. For overweight, we have 130, 69 for fit. Slightly overweight are 68, underweight are 22, and malnourished are 13 people in the data set. So we can check for gender as well. So for female, we have 255, and for male, we have 245. So these are the values we have over here. And now what we are going to do is we are going to make a, let's say, a count plot using the Seaborn library that we have. And first of all, we're going to check for the, wait, not for the index first, let's check for gender. Okay, wait, we have, so we have 255 values and 245 values. Now instead of gender, we check for index. And for extremely overweight, we have more than 2. We already have the count. I'm just getting a visual representation for it, so that it'll be easier to distinguish between, like, slightly fit people are, how many people are slightly overweight, how many people are extremely overweight. So it's very clear to understand this, and with the help of this visual representation, it's quite easy as well. Now what we are going to do is we are going to make a few more plots to understand the relationship between all these variables that we have inside this data set. So I'm going to use SNS, which is an alias for Seaborn library. I'm going to plot a relation plot for which X, let's say, is height, and for Y I'm going to give let's say weight, and we can also add the hue. So for this I'm going to add index, and data is equal to data. Okay, so we have our visual representation over here. So for index, we have malnourished, underweight, fit, slightly overweight, overweight, and extremely overweight people. So for extremely overweight people who are in the majority are over here in this part of the graph. So as you can see, most of them are overweight in terms of, I mean, the weight is almost more than 80. I mean, for 2 or 3 people it's 80, but basically their height is also very small, so they are considered extremely overweight, and it goes as high as 160. And for fit people, all these people lie around in this area, which is around, for an average height it would be around 170 centimeters, and for weight it's around 60 to 70, the average for fit people. For all this, you can figure out how many people are actually there. So for this slightly overweight people, we have this one little dot over here, which is height is 170, but the weight is quite closer to 120, which is considered as slightly overweight. So we'll take a look at the next plot that we have. So this is why visual representation is very useful, guys. So by looking at the data, you would not be able to figure out the relationship between height and weight for all these people, but you put it inside a graph and it's quite easier to understand. So this is why I was telling you in the last session also how important visual representation actually is. And now we are going to check the relationship between all these variables again and again, so that we reach to a conclusion, and we'll able to figure out what we have to do here. So instead of height, let's say I write it as index, and I want to check the hue as gender, which will be male and female, but in our case it will be 0 and 1, but 0 is depicting a female and 1 is depicting a male over here. So as you can see, guys, all right, I'll just add the height and aspect to make it clear. All right, so yeah, as you can see guys, malnourished people are okay, the height is pretty good for malnourished people guys. It's basically they are falling into that category probably because they are very tall, but the weight is not exactly how much it should be according to the body mass index. And similarly for the overweight people, it's quite distributed among all the categories of the height, and this is quite overwhelming also. The height is very uniform in all these cases. I mean, most of these blue dots that I'm seeing from 180 to 90 are females, so that's why they are falling under this overweight category, I guess. All right, so instead of height, let's check it for weight as well. All right, so if we check about weight, nobody is going to be overweight in this category from 0 to 60. Okay, so most of these people are falling under the category over 60 kilos, and then we have fit people falling under this category. And the last dot that I'm seeing over here, which is a male, is slightly over 100 in the weight category, and that's it. That's about it. So fit people are less than 100 kilos of weight over here in this whole data set that we have, and slightly overweight, then extremely overweight people, let's say. All right, so the average is falling around 120 Ks, and the minimum is 80 kilos. So that's quite clear in this diagram. So that's why I was saying guys, that's why you should actually master the art of visualization from the data set guys. So because that's how you know. All right, so I'm gonna make a few changes to this. So I'll add the kind as line, and let's see. Okay, as you can see, I think it's quite visible guys. So we have a straight curve guys from malnourished, it's going up. I think the male population is a little bit fluctuating in the fit section, but it's quite uniform for both the gender in each category. So let's check it for height as well. Okay, this is a little fluctuating in the middle for the fit section. So most of the fit people who are in the female gender are actually have a height of an average of 170, 175, and same goes for the male gender, that is on the yellow line. It goes around 172, 85. That's cool, but it is quite uniform as well if you look at it that way. So now we are going to move on guys, and we are going to make the model, a predictive model, to predict an outcome in this data set guys. So which is basically, I think you understood what I'm going to predict over here. So we are going to predict the body mass index, right? So for that we are going to use the SVC, or the objective of a linear SVC, which is also known as support vector classifier, is to fit to the data you provide, returning a best fit hyperplane that divides or categorizes your data. So let's just divide our data, which is going to be the X and Y. So for that, let's just okay, I'll just drop the column which is index from my data set. So X is going to be my training data guys, and Y is going to be my test data, which is going to be this column index. Alright guys, no errors there. Now before we move on, I want to talk about the support vector machine guys. So the support vector machine, it actually works by mapping the data to a high dimensional feature space so that data points can be categorized. And even when the data are not otherwise linearly separable, a separator between the categories is found, then the data are transformed in such a way that the separator could be drawn as a hyperplane. And if you want to know more about what exactly is a support vector machine, you can check out other tutorials on Edureka. So we have a support vector machine using Python and SVM using R programming also. So you should head out to our YouTube channel and check out those tutorials. Because this is and because we are gonna make a model for this, so I'm just going to execute the same. If you want to get into the technicality of what exactly it is, you should head out to the tutorial that we already have on Edureka. So what I'll do is I will use the X train, X test, Y train, and Y test using the train test split. So I'll tell you what exactly is a train test split over here, which I'm using. So it split the arrays or matrices into random train and test subsets. So the parameters in this we have are the test size, then we have the train size and the random state as well. So we're going to specify X and Y over here. Then we give the test size, which should be, a float should be between 0 and 1 and represent the proportion of the data set to include in the test split. So if integer represents the absolute number of test samples, and if none, the value is to be set to the complement of the train size. And if the train size is also none, it will be set to 0.25, but we are going to set this value to 0.2, and we'll take the random state as 0, right? So we have no errors here, guys. Now what I'm going to do is I am going to use the standard scaler that I had previously imported from the sklearn library. So it is nothing but, it is used to standardize the features by removing the mean and scaling to the unit variance. So what exactly is happening here is the centering and scaling happen independently on each feature by computing the relevant statistics on the samples that is in the training set. Mean and standard deviation are then stored to be used on later data using the transform. So standardization of dataset is a common requirement for many machine learning estimators, and they might behave badly if the individual features do not more or less look like standard or normally distributed data. But I can tell you guys in layman terms, if I don't use these statements that I'm going to write, the accuracy will be affected in my model. So that's why I'm going to write these standard scalar command, and after this I'm going to use xtrain is equal to s dot fit transform, and I'm going to write the value x train, and for x test it is going to be s dot transform x test. So no errors there again. Now what I'll do is I will classifier, let's say I'll write it as CLF, my classifier. So I'm going to use the svm dot svc support vector classifier, and after that I'm going to use the CLF to fit. And now what this fit actually is, the fit method is used, or the fit function is a generic term which is used to best match the curvature of a given data points. So this is basically used to fit the model, guys. So I'm going to use the x train, and I'm going to use the y train, and after this I'm going to take one variable that is going to be prediction. So it is using the CLF dot predict, and inside the predict I'm going to use the x test. Right, no errors there again. Now what I'll do is I'll check for the classification report. Alright, so I am going to print the classification report, guys. Or wait, I can just classification report, and inside this you have to produce y-test and your prediction variable. Now, alright, so okay, wait. So we have our classification report, guys. So I'm just going to tell you what it actually is so that you'll be able to understand this better. It is nothing but a classification report which is going to have precision, recall, F1 score, and support. So for all these values that are extremely overweight, fit, malnourished, overweight, slightly overweight, and underweight, we have the precision, the recall, the F1 score, and the support. And after that we have the accuracy, macro average, and weighted average as well. So when we call the classification report, it returns a text summary of precision, recall, F1 score for each class that we have. And the dictionary returned if output dictionary is true. Now, to compute the precision, recall, F measure, and support for each class. The precision is basically the ability of the classifier not to label as positive a sample that is negative, and the recall is nothing but the ability of the classifier to find all the positive samples. The F score can be interpreted as a weighted harmonic mean of the precision and recall, and the support is the number of occurrences of each class in Y true. So that is all about the classification report, guys. And talking about the accuracy classification score in multi-label classification, this function computes subset accuracy, which is the set of labels predicted for a sample must exactly match the corresponding set of labels in Y true. That's about it, guys. So we're going to do a few more things to see how our model is actually performing. So let's get a confusion matrix as well. Now the confusion matrix is nothing but it's gonna produce the true positive and false positives, and true positives and false negatives in a matrix format. So there we have, guys. And for checking the accuracy, there is one more thing that you can do, which is basically print the accuracy score. And the accuracy score, you have to provide the y-test and predict. So we have the accuracy of 0.85, which can be translated into 85%. So that's quite good, guys. Anything above 70, if you are a beginner, is a very good accuracy if you ask me. And now we're going to test this classifier for a new value. So what we'll do is we will write it as let's say x, or we can write it as a, and the value of a is, let's say, 1, and let's say it's a female. The height is about 160, and the weight let's say is 70, or weight, let's say 48, and we have a is equal to s dot transform, and then we have v is equal to classifier dot predict our a over here. So we have no errors, and now we are going to get the prediction, which is saying fit. So if you are a female and you have a height of 160 and the weight is 48, you are quite fit. So this is our prediction, guys. So let's check this in our data as well. So we have a data, guys. So if we have anybody, let's say, with the height of what we have mentioned, okay, 160. So for the first value we have 185, let's say. We add 185 over here, and the weight is 110, and for that value it is overweight. So we'll write that only, or we'll write 90 kilos. And when I predict this, it is slightly overweight, guys, which is not bad. And if I write it as, let's say, 110, and it is giving us the exact value that we were getting over here, that is overweight. So that is how you make a prediction model for any data set, guys. You just have to play with the variables, understand the relationship between them, and then you're just good to go. And now that we have come to the end of the session, guys, don't forget to subscribe to Edureka and hit the bell icon to get the latest updates on Edureka. And don't forget to enroll to data science certification program with Python. The link is given in the description box below. And in the next session, we are going to work on something really interesting. So tune in to our next session, guys. Until then, happy learning. Thank you.